Hello and welcome to the fourth section of this SQL project portfolio titled UK Train Right. In this fourth video, we are going to analyze the train right dataset and extract actionable insights for our clients. In the first part of this portfolio, we downloaded the dataset, created the database, and imported the table. The second video was focused on data cleaning, where we employed different steps to ensure our data met all quality requirements. In the third section, we engineered new features that are essential to our analysis. And now in this video, we are ready to begin to analyze our data. This fourth part of our SQL project will be divided into two sections. In this first section, here are the questions we hope to analyze and extract insights from our data. So let's dive into the workbench and begin to analyze our data. So we're in the MySQL workbench, and here are the schemas in this workbench. The schema of interest is the train right database. So the first thing we need to do is to select this database as the database that we're going to work on. So that's what we have here. So I have already pasted the questions that we're going to answer in the query tab. Okay, so let's start by selecting the database that we're going to work on. So to select the database of interest, we use the use statement. So use train right. So this statement, use train right, will select the database train right as the database that we're going to work on. So let's execute the statement. So the statement has been executed as shown in our action output. So, and if we look at the schema panel, we can see that the train right database has been highlighted. So the next thing to do is to show the tables that are in this database. If you take a look at the schema panel, we can see that there is only one table in this database, which is the railway. We can confirm that by also using the statement show tables. So this statement will show us the list of tables in this database. So by executing it, we have our results that in this table, that the tables in this train right database is just the railway table. Okay, so the next thing we need to do is to have a look at the data set in this table to see the columns that are in this table. So we will select the first 5 rows in our table. And to do that, we use the select statement. Select all columns. So asterisk is used to select all the columns in our table from our table called the railway. And we're limiting the results to the first 5 rows. We don't want to retrieve all the rows in our column. So this statement selects all column from our table, the railway, and limit the results to the first 5 rows. So let's execute the statement. So there is our result. Here is the first 5 rows in our table, and these are the fields in this our table. So here are the fields in our table that we're going to work on. Okay, we can now begin to analyze our data. The first question says, what is the total ticket purchased? So in this question, we want to count the number of tickets that has been purchased. And to do that, we need to count the transaction ID, because this transaction ID is a unique identifier for each ticket that has been purchased. So if we want to know the total ticket that has been purchased, then we need to count the transaction ID. So to do that, we use the select statement, select, then we are counting. So we use the function count. So the function count is going to count our transaction ID, and we are giving the result, and we are calling the result to be the total tickets. So we are selecting this from our table, the railway. So this statement is going to retrieve from our table the count of the transaction ID, and is going to call it the total ticket. So let's execute this statement. Okay, here is our result. From our result, we can see that the total ticket that was purchased was 31,653 tickets. So this is the total ticket that has been purchased. But our interest is the total ticket that was purchased in the year 2024, because some of these tickets were purchased earlier before 2024, since tickets can be purchased in advance. So we can confirm this by retrieving the earliest date the ticket was purchased. So we want to confirm that some of these tickets were purchased earlier than January 1st, 2024. We do that by using the select statement, select. So to retrieve the earliest date of purchase, we use the min function. We use the min function to retrieve the minimum date of purchase, and we are calling it the earliest purchase date. We also need to retrieve the earliest date of journey. So by also using the min function, min date of journey. So we'll call it the earliest journey date from our table, the railway. So this statement will retrieve the earliest date of purchase and the earliest date of journey. So let's execute the statement. So here is our result. And based on our result, the earliest date of purchase of our ticket was on 8th December 2023. But if you look at the earliest date of journey, the earliest date of journey was on 1st January 2024. So what this means that some tickets were purchased earlier than 1st January 2024. So we need to calculate the total number of tickets that was purchased only in 2024. Our focus will be on what happened in 2024. So we need to rerun our statement. This statement, we need to count the total ticket for tickets that were purchased in the year 2024. So I'll copy this statement and paste it below here. So this statement will count the total transaction ID, but we are going to put a condition, and that condition will be where the year of our date of purchase is equal to 2024. So we are adding a filter. The filter is that we want to count the transaction ID for ticket that was purchased in the year 2024. We are using the year function to retrieve the year from this our column, the date of purchase. So by executing this statement, that gives us that the total ticket purchased in 2024 was 31,619 tickets, as opposed to the total ticket that was purchased, which was 31,653 tickets. So for the year 2024, the total ticket that was purchased was 31,619 tickets. Next, we need to export this our result into an Excel workbook, which will later be used in the fifth section of this portfolio, that is to prepare our presentation for our client. So we need to save this our results in an Excel workbook. To do that, we need to export by clicking on this icon, export. This will open a dialog box which will ask us the location where we want to save this file. I want to save this file in the folder, the train ride analysis that I created during the first video in this portfolio project. So this file is saved as a CSV file and it is being called the file name total tickets. So let's save the file. So this is what we do for all the results that we're going to get during this analysis. So we'll save the results in an Excel workbook so that we can use it during our presentation. The second question says, how many of these tickets are purchased on average each day? So in this question, we want to know the number of tickets that were purchased each day on average. So to do that, we need to count the total number of tickets and divide it by the total number of days. So this will give us the average number of tickets that was purchased. So our statement will be select, we count the transaction ID and we divide this count by the total number of days. So to get the total number of days, we will use the datediff function. The datediff function will calculate the difference between two dates and return the result as number of days. So we use the datediff. This datediff takes two arguments, and those arguments will be the two dates column that we want to subtract. The first column it will take will be the latest date of purchase. So to retrieve that, we use the mass function. The mass function will be used to retrieve the latest date of purchase. So the second argument is the earliest date of purchase, which will be retrieved using the min function. So the min function will be used to retrieve the earliest date of purchase. So these are the two arguments that this datediff function will take: the latest date of purchase and the earliest date of purchase. So this will retrieve for us the difference between the two dates, and we want to call this result the average tickets purchased each day. So average tickets per day. So this will be retrieved from our table, the railway, and we are focusing on the tickets that were purchased in the year 2024. So we are going to add a where clause. So where the year of our date of purchase is equal to 2024. So this statement is going to count the total ticket purchased in the year 2024 and divide it by the total number of days and return the result as the average ticket purchased per day. So let's execute this statement. So the statement has been executed successfully, and based on our results, we can say that on average 263 tickets were purchased each day in the year 2024. Question number 3 says, where do they purchase the tickets and how do they pay for it? So in this question, we want to know where our passengers are purchasing the ticket from and what method of payment are they using to pay for the tickets. So to start with the first question, which is where the passengers are purchasing the tickets, we need to count the total number of tickets and group it based on the purchase type. So we use our select statement, select our purchase type, and we are counting the transaction ID and calling it the total tickets from our table, the railway, and we are doing this for tickets that were purchased in the year 2024. That is, we are using the date function, we are using the year function to retrieve the year from the column date of purchase. So where the year is equal to 2024, and we are grouping our results by the first column, which is the purchase type, and also sorting the results by the total tickets, which is the second column, and we are sorting it in descending order. So this statement will count the transaction ID as the total ticket and group it based on this column called the purchase type, and we are doing this for tickets that were purchased in the year 2024. So let's execute this statement. So based on our results, there are two places where our passengers are purchasing the ticket from. It is either they're purchasing the ticket online or they're purchasing it directly at the station. And these are the total tickets that were purchased online: 18,498 tickets, while at the station, 13,121 tickets were purchased there. So to be able to report this total ticket purchase, we need to report it as a percentage. So we need another column which will show us the percentage of these tickets that were purchased. So we need to add the percentage. So we'll go back to our select statement and I'll add another column. So this column will be the percentage. And how do we get the percentage? We are going to count each of these tickets purchased based on the purchase type and divide it by the total ticket that were purchased. So we are using the count statement to count the transaction ID and we are dividing the result by the sum of the count of our transaction ID. So we are using the window function to do that. So, and we are calling this as the percentage of the tickets that was purchased. So this statement is going to count the transaction ID as the total ticket. Remember, we are grouping based on the purchase type, and after it has counted the total ticket based on the purchase type, it's going to also sum the count of these total tickets, and these two counts are going to be divided so that the total tickets based on the purchase type will be divided by the sum of the total ticket that was purchased. So that's why we're using the window function to perform this calculation. So let's execute this statement. So based on our results, we can see that about 58% of the tickets were purchased online, while about 41% of the tickets were purchased at the station. So we can be able to report this, that 58% of our passengers are purchasing the ticket online, while 41% of our passengers are purchasing the ticket at the station. So to answer the second question, which is how are the passengers paying for the ticket, we need to count the total transaction ID and group it based on the payment method. To answer this question, we select the payment method and then we count the transaction ID as the total ticket from our table, the railway, and we are doing this for tickets that were purchased in the year 2024, and we are grouping by the first column, which is our payment method, and we are also ordering the result based on the total ticket, which is the second column, in descending order. So this statement will select the payment method and count the total tickets purchased in the year 2024 and group the result based on the payment method and also sort the result based on the total ticket that were purchased in descending order. So let's execute this statement. We have our results, and based on our results, there are three methods of payment that the passengers are using to pay for the tickets. They are paying either using the credit card or the contactless method or using the debit card. So these are the number of tickets that were paid using this payment method. So to be able to report this, we need to know the percentage for each of these payment method. So we're going to add another column which is going to calculate the percentage of the total tickets that were purchased using this payment method. So to do that, we'll add another column. This column, we are going to count the transaction ID and we're dividing the result by the sum of the count of the transaction ID and we're performing this using the over function. We call the result the percentage of the tickets. So in this our statement, we have included the percentage of the ticket that was purchased. So let's execute this statement. So based on our result, we can see that 60% of our tickets were purchased using the credit card, 34% were purchased by the contactless method, and then 5% were purchased using the debit card. Meaning that majority of our passengers, more than half of our passengers, are purchasing the ticket using the credit card. Question number 4 says, how many departure stations and arrival stations do we have? So in this question, we want to know the total number of departure stations and the total number of arrival destinations that are in this our data set. So to answer this question, we need to count the number of distinct arrival destinations and the number of distinct departure stations. So we are going to use distinct keywords to count the number of distinct arrival destinations. So our statement will be select. So what are we selecting? We are counting the distinct departure station and we're calling it as our departure station. We are also counting the distinct arrival destination, and we are calling it arrival destination from our table, the railway. So this statement is going to count the distinct departure station and also count the distinct arrival destination that we have in our data set or in our table called the railway. So let's execute this statement. Okay, from our results, we have that there are 12 departure stations and also there are 32 arrival destinations. Question number 5 says, what are the total routes plied by the train? So in this question, we want to know the total route that our trains take whenever they leave the departure station to arrive at their destination. So what are the total routes that are plied by our train? So to answer this question, we need to get the unique departure station and the arrival destination. And after that, we count these as the total route that is plied by our train. So to answer this question, we start by using our select statement to select our departure station. We also select our arrival destination, and then we count the transaction ID and call it the total rides from our table, the railway, and we group the result by the first two columns, which are the departure station and the arrival destination. So this statement, we select the departure station and the arrival destination and count the total rides and group the result by the departure station and arrival destination. So let's execute this statement. Okay, so here are the unique departure station and the arrival destination that we have. And based on our action output, we have 65 rows returned. So this tells us that there are 65 unique routes that are applied by our train. So to be able to return the result as 65 routes, we need to use a subquery or we use a common table expression. So first of all, we're going to use the subquery. We're going to enclose this statement within another query. That's what subquery is all about. We're going to enclose this our select statement inside another query and then count the total number of routes that was returned by this statement. So we're starting with the subquery. After that, I will show you how to do that using the common table expression. So to use the subquery, I said we are enclosing this statement. So this statement is what we're going to enclose within a query. Okay, so to do that, we're going to enclose this in a bracket. So I've enclosed this in a bracket, and this our statement, we're going to give it an alias, and the alias we're giving it is our route. So this statement will be in the from clause. So from this, so we're going to now select, and what are we selecting? we are counting all the rows. So this statement is going to execute first what we have within this from cross. So it's going to select the departure station, arrival destination, and count the total rides. And after that, whatever we have from this statement, we're going to count all the rows that are returned. So this is what we have as our subquery. So let's execute this statement. So based on our result, we can see that we have 65 unique routes that is being applied by our train. So our result did not give us a unique name. So we're going to add an alias. So as unique routes. So let's rerun this statement. Yes, so we have our result that there are 65 unique routes that is being applied by our train. Okay, we have been able to find the total route, and here we use the subquery method. So I want to show you how to also execute this statement using the common table expression. So what we want to do is that we want to also find the total route that is applied by our train, but this time around we are using the common table expression. So to use the common table expression, first of all, let's copy the query that we ran before. So this statement will retrieve the unique routes that are applied by our train. So, but we want to return the total number of these routes. And to do that, we said we are going to use the common table expression. So using the common table expression, we are going to enclose this statement within the with clause. This will give us a temporary table which we can now count the number of rows in that temporary table. So what we do is that we're going to enclose this statement, and we're enclosing it inside a with clause. So I'm going to enclose this statement inside a with clause with routes as. Okay, so we are calling this temporary table routes. So the with clause will execute this statement and create the temporary table. So whatever we have here, what we're going to do is that we're going to run another select statement, and then we will count all the rows that we have in that temporary table and call it as the total routes. So the table we are selecting this count is going to be from our table called the routes. Okay, so this is our statement. So the first thing our statement does is that it's going to run this statement and return a table that contains the unique routes that are being applied by our train, and store the result inside a temporary table called the routes. And then this our second statement will now count the number of rows in that table that was returned. So let's execute this statement. So based on our result, we can see that we have 65 total routes that are being applied by our train. So this is how to use the common table expression to perform the same thing that our subquery did. Question number 6 says, what are the most plied routes and what are the least plied routes? So in this question, we want to know the routes that are being applied mostly by our train, and also know the least applied routes by our train. So we are going to return the route with the total number of rides for each of these routes, and then we sort our result in descending order to be able to get the most applied route, and after which we sort our result in ascending order in order to be able to get the least applied route. So we start with the most plied route. So to do that, we use our select statement to select the departure station. We also select the arrival destination, and then we count the transaction ID as the total ride from our table, the railway, and we group our result by the first two columns, and then order the result by the third column, which is the total ride. And we're ordering it in descending order. So we want to retrieve the top 10 routes plied by our train. So we use the limit keyword to limit the result that is being returned to the first 10 routes. So let's execute the statement. So these are the top 10 most plied routes. So we can see from our results that Manchester Piccadilly to Liverpool Lime Street is the most plied route with about 4,628 total rides, followed by the London Euston to Braham New Street. So this is the second most plied route, and our third most plied route is the London King Cross to York. So this is the result of the 10 most plied routes. So to get the least plied route, we need to run the same statement. I'll copy the statement and paste it below here. So what we need to do is just to change the order of our results. So we are ordering the result in ascending order. So by changing it, our result will now be the top 10 least plied routes. So let's execute this statement, and we can see from our result that the least plied route is the Liverpool Lime Street to Braham New Street. So it has a total of 14 rides. So these are the least plied routes. Question number 7 says, how many rides were successful and how many rides were cancelled? To answer this question, we need to know what a successful ride is. A successful ride is a ride that is completed. That is, a ride that reached its destination. Such a ride could be on time or delayed. So what we need to do is to count the rides that were both on time and delayed as successful ride, and also count the rides that were delayed. So this will tell us the number of rides that were successful and also the number of rides that were cancelled. So we're going to use case statement to be able to group our ride into successful rides and cancel rides. So let's write the statement. So we're going to use the select statement. Select. What we need to do is to use the case statement to be able to group our ride into successful rides and cancelled rides. So case, when the journey status is any one of the following. So when journey status is in on time or delayed, then we should call it a successful ride. So what this statement will do is it's going to check our column called the journey status, and whenever it sees any of these two values, on time or delayed, is going to group it as successful writes. Okay, but when the journey status is equal to cancelled, then we should call it a cancelled write. So what this second statement will do is it will check this journey status column, and whenever it sees cancelled as any of the value, it should group it as a cancelled write. So we'll end this our case statement, and we're going to call it the journey status. So this statement is going to check the column, the journey status, and group these two values as successful write, and also group the cancelled value as cancelled write. Okay, so what we need to do next is to count the transaction ID as our total writes from our table, the railway, and group our results based on our journey status, which is column number 1. So let's execute this statement. So we can see from our results that we have two journey status, the successful writes and the cancel write. We have that 29,773 writes were successful or completed, while 1,880 writes were cancelled. To be able to report this result, we need to find the percentage for each of these writes. So we need to add the percentage. So we'll go back to our statement and add another column, which is going to count the transaction ID and divide the result by the sum of the count of the transaction ID, and we're using an over function to do that. So we are calling this as the percentage writes. Okay, we need one more bracket here. We are adding the percentage of each of these writes. So let's execute this statement. We can see that we have 95% of successful writes, while the cancelled write is just about 6%. Question number 8 says, what percentage of the successful writes were untimed and what percentage were delayed? In question number 7, we were able to calculate the total writes that were successful and also the total writes that were cancelled. And we found that 29,773 writes were successful. So out of these successful writes, what percentage were on time and what percentage were delayed? So we need to find out how many of these writes were on time and how many were delayed. So to answer this question, we run the statement select. What are we selecting? The journey status. So we'll select journey status, and then we will count the transaction ID and we call it the total writes from our table, the railway, and we're going to filter out only those writes that were on time and those writes that were delayed. So we're going to use a where clause where the journey status is in, so where the journey status is any of these categories. So we're using the in clause to specify that the journey status can either be on time or that the journey status can either be delayed. So these are the two categories of our successful writes. Then we'll group our results by that first column, which is the journey status. So this statement will retrieve the journey status where the journey status is either on time or delayed, and it's going to count the number of tickets that were purchased and call it the total rides, and we are grouping the result based on that journey status. That is, we are grouping based on either the ride is on time or delayed. So let's execute this statement. So we can see from our result that 27,481 rides were on time, while 2,292 rides were delayed. So let's calculate the percentage of these on-time rides and delayed ride. So we're going to add percentage. So we count the transaction ID and we'll divide the result by the sum of the count of this transaction ID, and we're doing that using the window function. So we are putting the over clause. So we are calling this as our percentage right. So let's execute the statement. So from our result, we can see that 92% of our successful rides were on time, while 7% or approximately 8% of these completed rides were delayed. Question number 9 says, what is the minimum, maximum, and average delay time? So for those rides that were delayed, we are interested to know the minimum delay time, what the maximum delay time is, and what the average time of delay is. In order to be able to calculate the delay time, we need to get the difference between the actual arrival time and the arrival time. The arrival time is the time the train is supposed to arrive at the destination, while the actual arrival time is the time the train actually arrived at the destination. So if our train was delayed, then the actual arrival time should be higher than the arrival time. So by getting the difference of these two columns, we will get our delay time. And from there, we can be able to get the minimum delay time, the maximum, and also compute the average of this delay time. So to achieve this, we will use a function called time diff. So time diff returns the difference between two time columns. So we'll run the statement, select our time diff. So this time diff takes two arguments. So the two arguments are the two time column, and the first argument is our actual arrival time, while the second argument is the arrival time. And we are calling this result the delay time. So we are selecting this from our table, the railway, and we're putting a condition because we're only interested in those rides that were delayed. So we're using our where clause where the journey status is equal to delayed. So we only want to return the difference between the actual arrival time and the arrival time where the journey status is delayed. So for all the rides that were delayed, we will calculate the difference between their actual arrival time and arrival time. So let's execute this statement. So here is our result. These are the difference between the two columns. We have for the first record that the delay time is 12 minutes, the second one says 50 minutes, the third one is 55, fourth one 43. I can see the sixth record says that the delay time was 2 hours 47 minutes. So these are the delay time. Next is to convert this time to minutes. Since we are seeing that some of this time were in minute and some were in hour, so we need to convert all this time to minutes. And to do that, we will convert the time first to seconds and then divide by 60 to have those times in minutes. So we're going to use another function called time to second. This function called time to second converts our time column to seconds. So if we have the time in seconds, then we can divide by 60 to have the result in minutes. So this our column, we are going to enclose it in a time to second function. So we have time to second. So this function, let's put our closing brackets. This function will convert our time, this time that we're seeing here, to seconds. So let's execute it. So we have the time in seconds. These are the values in seconds. Then we need to convert it to minutes by dividing by 60. Okay, so let's execute it. Now we have our time in minutes. So it has converted the time from seconds to minutes. And we did that by dividing by 60. Now that we have gotten the time in minutes, we can now compute the minimum time of delay, the maximum time, and the average time by using the aggregate function mean, max, and average, which is AVG. So we are going to store this our delay time in a temporary table using our common table expression. So I'm going to enclose this statement inside a with clause. Okay, so I will close this with an opening bracket. Then outside this bracket, I'm going to use my with clause with. I'm going to call this table delay time as. Then the next thing to do is to close the bracket. Then we need to now compute the minimum, maximum, and the average delay time. So we will use our select statement, select, and what are we selecting? We are selecting the minimum. So minimum delay time, that's the name of the table or the column, as minimum delay time. So we are using the alias mean delay time to represent the minimum delay time. Also, we want to get the maximum delay time, so we use the max function to get the maximum delay time, and we are calling it the max delay time. And the last one is our average. So we use the AVG function to get the average of the delay time and call it the average delay time. And from the table we are selecting is this our temporary table that we called the delay time. Okay, so let's execute this statement. So we have our results. Our result says that our minimum delay time is 0 minutes. The maximum is 180 minutes, that's about 3 hours, and then the average delay time is 42 minutes. So the question is, why is our minimum delay time equal to 0 minutes? Why are we having 0 minutes as our minimum delay time? Because if a ride is delayed, then the minimum delay time should have values that is greater than 0. So why are we having 0 as our minimum delay time? So to investigate on this, we need to filter out those rows where the delay time is equal to 0 and be able to find out why are we having 0 as our minimum delay time. So we'll go back to our statement. So here is our statement, and we'll copy this statement. So let's paste the statement here. What we are doing is that we are checking why the minimum delay time is equal to 0. So we are investigating on why the minimum delay time is equal to 0. So let's paste our statement here, and then inside this statement we want to retrieve all the rows. So we'll go to our with clause. Inside the with clause, we're interested in getting all the rows and at the same time getting the delay time. Okay, and then what we are interested now is to only retrieve the rows. We're going to remove this, our mean, mass, and average, and then replace it with an asterisk. So we are interested in all the rows where the delay time is equal to 0. So this is our statement. Inside the with clause, we are retrieving all the columns, and also we are retrieving the column called the delay time, which we have computed for all the records where the journey status is delayed, and we are only interested in all the rows where the delay time is equal to 0. So let's execute this statement. So this is our results. Let's see our action output. Our action output says that 18 rows are returned. So if we investigate on this, we can see that the journey status for these records were delayed. So these tickets were delayed, but looking at our arrival time and actual arrival time, I'm seeing that the arrival time here is 1920, and it is the same with our actual arrival time. The same with the second row and the third row, even the fourth row have the same. So meaning that there is possibility that there was an error in imputing these 18 records. So it's either the person that imputed this record made a mistake in the actual arrival time and didn't enter the correct actual arrival time, or that the person made a mistake in the journey status by stating that these tickets were delayed. But based on the fact that they say that this ticket was delayed, we are actually seeing the reason for the delay. So I am inclined to believe that these tickets were delayed, that the mistake is from the actual arrival time, that they didn't enter the correct actual arrival time for this 18 record. So we'll go back to our statements where we calculated the mean, max, and average, and we're going to put a condition that we do not want those that we want to calculate the mean, mass, and average for all the records where the delay time is greater than 0. So we're going to use a where clause, and our condition will be where the delay time is not equal to 0. So this will exclude those records where the delay time is equal to 0 and calculate only for those records where the delay time is greater than 0. So let's execute this statement to get the actual values for the minimum, mass, and average delay time. Okay, so that's what we are seeing our results here, that the minimum delay time is 1 minute. The maximum delay time is still our 3 hours, that's 180 minutes, and then the average delay time is about 42 minutes. So this will be the correct result for this analysis. Question number 10 says, what are the reasons for the delay rights and what are the reasons for the cancelled right? So in this question, we want to find out what were the major reasons for delay and cancellation of the rights. So we need to count the number of rights based on the column called reason for delay. So let's start with analyzing the reasons why the rights were delayed. So our first focus will be to find out the major reason for delay. After that, we can be able to calculate the major reason for cancellation of rights. So we are starting with analyzing for reasons for delay. So we use our select statement. Select the column we are selecting is the column called reason for delay, and then we are counting the transaction ID as our total rights from our table called the railway, and we're using the condition where the journey status is equal to delayed. So we're only interested in those rights that we are delayed, and then we are grouping our results by the first column, which is the reason for delay. So we'll order the results by our total rights, column 2, in descending order. So let's execute this statement. So we can see from our results that there are 7 major reasons for delay. That's, we're seeing 7 rows were returned. So there are 7 major reasons for delay, and the major reason for delay is weather. So the reason why most rights were delayed was due to weather condition, followed by technical issue, which has about 472 rights delayed because of technical issue, and then the third reason being due to signal failure, with about 451 rights delayed. So let's compute the percentage of each of these delay rights. So we're going to add percentage to our result. So we count the transaction ID and we divide by the sum of the count of this transaction ID, and we're doing that using the over clause, and we're calling it our percentage delay rights. Okay, so let's execute the statement. Now from our result, we can see that 33% of the delayed rights were due to weather condition, due to bad weather condition, and then 20% of the delayed rights were due to technical issue, and 19% were due to signal failure. So here is our 3 major reasons for delay of train rights: the weather condition, technical issue, and signal failure. So next, we want to find out the reason why our rights are being cancelled. So what we're about to do is to find the major reasons for right cancellation. So what we do is that we are going to copy this, our previous statement, and then paste it. The only thing we are changing here is the journey status. We are interested in the rights that we are cancelled. So we remove the delayed and change it with cancelled. So this statement will return for us the major reasons where our rights are being cancelled. So let's change the percentage delay to percentage cancel. So this will be the percentage of the rights that were cancelled. So let's execute this statement. Okay, so from this our result, we can see that the major reason why our rights were cancelled is due to signal failure. which had about 27% of the rights cancelled. So followed by staffing and then weather condition. So we have that the major reason is signal failure. Every other reason had almost the same contribution, but the signal failure had the highest reasons for cancellation of ride. That's about 27% of those rides that were cancelled were due to signal failure. This brings us to the end of this first part of our analysis. In the second part of the video, we hope to answer the remaining questions that we have for this analysis. So I will see you in the next video.